I want to make sure we take a look at one more infinite limit because I think this is a pretty tricky topic. These are hard problems, so I want to have one more example to look back on if we need to. So here I'd like to evaluate the limit as x approaches -3. Here we've got x minus 1 over 2 times the quantity x plus 3 quantity squared. So if I have a rational function like this, if I have a fraction, the first thing I'm going to try and do is factor this function. In this case, it's already factored. There's nothing more that I can do. Now, if you're not sure that this is going to be an infinite limit, and really if you're not sure where to start on any limit problem, I'm going to start by just taking that x value and plugging it into my function. So I'm going to just take x equals -3 and plug it in, and we'll see what happens. So that would give me -3 minus 1 over 2 times -3 plus 3 squared. In my numerator, I've got -4. My denominator, 2 times 0 squared, but 0 squared, that's really just 0 times 0, which is 0. So I have 2 times 0, -4 divided by 0. So this on its own is not really, it's not an acceptable answer. We can't just leave it here and say, well, our answer is -4 divided by 0. We also can't say that this limit does not exist because there's something else going on here. Remember, when we have a number divided by 0, that tells us that we have a vertical asymptote at this particular x value. We've got a vertical asymptote at x equals -3. So in a situation like this, if you're looking at a one-sided limit, then you can just look at that one side. But here we're looking at a two-sided limit. We want to look at the limit as x approaches -3. So that means I'm going to have to break this down into two separate parts. I'm going to have to look at the left-hand limit, and then I'm going to have to look at the right-hand limit. So let's look at that. Let's look at limit as x approaches -3 from the left of our function x minus 1 over 2 times x plus 3 squared. And again, I'm going to use the same trick that I did when I was looking at vertical asymptotes before. I'm going to take a number that's close to -3 that's on the left-hand side. So how about x equals -3.1? We'll plug that in. We'll see whether we get a positive number or a negative number, because I know that this limit has to be either positive infinity or negative infinity. So here, if I were to plug that in, -3.1 minus 1 divided by 2 times -3.1 plus 3 squared. In my numerator, you can find the exact value if you want, but really we just need a positive number or a negative number. We just need that sign. So if I were to take -3.1 minus 1 and subtract those, I'm going to get some other negative number. 2 is a positive number. We'll leave it as that for now. -3.1 plus 3, I know that if I were to add those two numbers, I'd get a negative number. And here we've got a little bit more work to do. We can actually kind of keep going with this, though, because we know how negative numbers and positive numbers behave. My numerator isn't going to change because nothing's happening up there. And my denominator, though, if I were to take a negative number and square it, I'm just looking at this piece right here. A negative number and square it, that means I'm taking a negative number times a negative number. Well, that should give me a positive number. And then if I look at my denominator one more time, here I've got a positive 2 times a positive number. That's going to be another positive number. So my numerator is still negative. My denominator, though, is positive, which means that this is going to be a negative number, which tells me then that my limit up here should be negative infinity. So we know that the left-hand limit is negative infinity. But because we're doing a two-sided limit, we do need to check the right-hand side as well. So we'll look at the limit as x approaches -3 from the right-hand side of x minus 1 over 2 times x plus 3 quantity squared. And this time we'll take a number that's close to -3 on the right-hand side. So here I'm going to take x equals, say, negative 2.9. Be careful when you're working with negative numbers. It can be very easy to kind of mix up whether we're talking about the left-hand side and the right-hand side. If you need to, maybe take a moment to draw out a number line and say, here's negative 3. On the left-hand side, here's negative 4. Here's negative 2. So here would be negative 3.1, and here would be negative 2.9. Just to help you get an idea of what kinds of numbers we need to be working with. When we're working with negative numbers, I find it's easy to make a little mistake like that. So I'm going to take negative 2.9, we'll plug it in. So here I've got negative 2.9 minus 1 over 2 times negative 2.9 plus 3 squared. And again, if you would like to find the exact number, absolutely you can. Go ahead, be my guest. But we just care about the sign. Negative 2.9 minus 1, if I subtract those, I'm going to get a negative number. I'll just carry the 2 down here. Negative 2.9 plus 3, though, when I add those two, I'm going to get a positive number, square it. So if I just look at, make sure we follow our order of operations here. If I take a positive number and square it, I'm going to end up with another positive number. And then if I take 2 times a positive number, a positive 2 times a positive number, I'm still going to end up with a positive number. So I end up with a negative over a positive gives me a negative number. So that means that this limit should also be negative infinity. So we have that the left-hand limit is negative infinity. We have that the right-hand limit is negative infinity. So we can go ahead and draw the conclusion then that the two-sided limit must also be negative infinity. And there is our answer. So that's how we're going to take a look at the problem. The one thing I want to kind of make special mention of here is it's very easy to kind of gloss over the beginning part of this problem because we didn't spend that much time with it. But there's some really important information there. When we ended up with negative 4 over 0 and we said, okay, that is a vertical asymptote, that's what then allowed me to continue on with this thought process. Everything I did after that point only works because we know we have a vertical asymptote there. If we had ended up with some other number, if we ended up with, say, negative 4 divided by 1, then that would be our answer. That would be it. We'd be done. But because we know we have a vertical asymptote, we know that our answer should either be positive infinity or negative infinity, and we just need to figure out which one. The only exception to that rule, the one thing I'll mention here, is if we do end up, if we were looking at another problem and we ended up with the limit as x approaches, let's just say 2 from the left of some function f of x, let's say that ended up being positive infinity, and the limit as x approaches 2 from the right of f of x is, say, negative infinity. Well, we can use what we know about limits. The left-hand limit is positive infinity. The right-hand limit is negative infinity. So if I wanted to say anything about the two-sided limit, I'd have to say that that limit does not exist.